Example 11.1. Show that the coefficient of area expansion alpha A of a rectangular sheet of the solid is twice its linear expansivity alpha L. Linear expansivity or coefficient of linear expansion, it is one of the same thing. Now see here, suppose we have the rectangular sheet with sides A and B. So original area, that is A into B. Now suppose due to increase in the temperature of the sheet by delta T, the side A is increased by delta A and side B is increased by delta B. So here we can say the area of the sheet is increased by this part delta A plus this part delta B plus this part delta A3. Okay, so increase in the area of the plate delta A, that is delta A1 plus delta A2 plus delta A3. Now this delta A1, so this side is delta B, this side is A, so that is A into delta B. Then delta A2, for that this particular side, that is B, and this side is delta A. So delta A2, that is equal to B delta A. And delta A3, this side is delta A, this side is delta B. So delta A3, that is delta A into delta B. So resultantly we can write increase in the area delta A, that is equal to A into delta B plus B into delta A plus delta A into delta B. But for this particular linear expansion delta B, we can write delta B, that is alpha L B delta T. For this linear expansion delta A, we can write B into delta A, that is alpha L A delta T, then delta A into delta B, alpha L A delta T, alpha L B delta T. Now from these three terms we can take alpha L into A into B into delta T common. So here first term 1, take this common, so 1, and from this one when we take alpha L, A, B and delta T common, means we will have alpha L into delta T. So now we can write alpha L, A, B delta T, that is 2 plus alpha L delta T. But alpha L coefficient of linear expansion, that is very small, that is of the order of 10 raised to minus 5. So we can neglect this particular term compared to 2. So we can write delta A, that is alpha L A into B into delta T into 2. But A into B, that is original area A. So 2 alpha L into A into delta T. But now see here, delta A, that is 2 alpha L A delta T. But in the theory of area expansion, we studied this thing, delta A, that is equal to alpha A into delta T. So from this one we can write alpha A, that is 2 alpha L. Clear to all of you? Suppose we have a rod and that is fixed from both the ends, and if its temperature is increased, then its length will increase. But if it is fixed from both the ends, then stress will be developed, and that is called thermal stress. અને આ thermal stress કેટલું મોટું હોય એનું આ એક સિમ્પલ એક્ઝામ્પલ આપ્યું છે. અને ડ્યુ ટુ ધેટ આપણે કેટલીક એપ્લિકેશનમાં આ વસ્તુ ધ્યાન રાખવી પડે છે. તમે રેલવે લાઇન્સ જોયેલી છે બધાએ, રેલવે ટ્રેક જોયેલા છે બધાએ, બરોબર? નાઉ if you observe it, then between two rail track there is a simple gap, slight gap is there. દરેક રેલ જે છે ને, એટલે કે એ જે પાટો છે રેલવેનો, બરોબર છે, તો એ એક પાટો પૂરો થાય પછી બીજો પાટો ચાલુ થાય તો વચ્ચે થોડીક આટલી ગેપ રાખેલી હોય છે ઓલવેઝ. પછી એ પાટો પાછો પૂરો થાય એટલે ફરી પાછી થોડી ગેપ હોય અને પછી બીજો પાટો ચાલુ થતો હોય. એનું રીઝન શું છે? જો બંને આપણે ટચ કરી દઈએ આમ બંને પાટા, વચ્ચે ગેપ ના રાખીએ તો ટેમ્પરેચર ઇન્ક્રીઝ થાય તો ડ્યુ ટુ થર્મલ એક્સપાન્શન લેન્થ ઓફ ધ રેલ વિલ ઇન્ક્રીઝ. હવે જો બંને એન્ડ ઉપરથી એ પેક કરી દીધેલો હોય તો થર્મલ સ્ટ્રેસ ડેવલપ થાય, અને એ થર્મલ સ્ટ્રેસ એટલું બધું મોટું હોય કે જ્યાં એને ફિક્સ કરેલો છે ત્યાંથી એનું બેન્ડિંગ થઈ જાય. જો કેલ્ક્યુલેટ કરીએ, સપોઝ લેન્થ ઓફ ધ સ્ટીલ રેલ that is 5 meter, area of its cross section that is 40 centimeter square, so that is 40 into 10 raised to minus 4 meter square. Now suppose its temperature is increased by 10 degrees Celsius only. Now coefficient of linear expansion for steel that is 1.2 into 10 raised to minus 5 Kelvin inverse. Okay. Now compressive strain, that is delta L by L. So that is alpha L into delta T. That is equal to 1.2 into 10 raised to minus 5 into 10. So that is 1.2 into 10 raised to minus 4. Okay. Now why steel that is given to you 2 into 10 raised to 11 Newton per meter square. Okay. Now Young modulus, that is stress upon strain. So stress that is force upon area, so that is y into strain, so that is y into delta L by L. Now delta F, the increase in the force, that is ys delta L by L into A. Y steel, that is 2 into 10 raised to 11 delta L by L, that is 1.2 into 10 raised to minus 4. Area, that is 40 into 10 raised to minus 4. If you solve this one, your answer that will be nearly equal to 10 raised to 5 Newton. Tremendous large force will exert. Clear to all of you? And due to this one,
Yes, sir.
the bending of the rail will take place.